Hello friends. Do you remember in 2014 there was a blockbuster film by director Christopher Nolan, the movie Interstellar. In this film, space-related concepts such as wormholes, black holes, alien planets were described in a scientifically accurate way. But perhaps the most shocking scene was at the end of the film, when in the climax, the main character of the film, that is Cooper, falls into a black hole. In the film, the name of the black hole was Gargantua. Cooper falls into the black hole with his spacecraft. Initially, everything was black all around him, complete darkness, but as he falls deeper, he notices some grain-like particles, and these particles hit his spacecraft and cause scratches on it, and there were some flashes of light, some sparks, and his aircraft catches fire. He was forced to leave from his spacecraft and he kept falling into the black hole. And suddenly he found himself in a 5-dimensional space. That is, a 5D tesseract. It was a mind-boggling experience. A place where he could communicate with his past self by using gravity. Seeing these scenes, you might have wondered if it is actually possible. Does this exist in a black hole? If we fall into a black hole, what will we see? Let's try to understand these aspects in today's video.
Black holes remained largely unknown until the 20th century. A black hole is a region in space where the force of gravity is so strong not even light can escape.
From the outside, you can't tell what is inside a black hole.
Black holes haunt our universe, dark centers of gravity that swallow everything in their path.
Let's begin with the beginning of the story. The history of black holes isn't very long. 100 years ago, no one knew what black holes are. Because of Einstein's theory of relativity, black holes were later discovered. There are two parts of the theory: the special theory of relativity and the general theory of relativity. The special theory of relativity, published by Einstein in 1905, tells us how speed influences the time. If you are in a spaceship that is going very fast, if the speed is too high, time will slow down for you relative to the people not on the spaceship. The word relative is very important because when you are in a spaceship, you won't feel the time slowing down. You would think that the time is flowing at the same speed as it normally does. But when you get back to the earth, you will find out that there was a difference in the flow of time. This is known as kinematic time dilation. Not only speed, but even gravity can also result in time dilation, as shown by Einstein in his general theory of relativity. This was developed by him in the year 1915. The more gravitational force you'd experience, the more time would slow down for you. This is known as gravitational time dilation, and this was depicted amazingly in the film Interstellar. When Cooper and his team land on Aqua Planet, 1 hour on that planet equals to 7 years on Earth. This happens on the planet because the planet was very close to the Gargantua black hole. So the gravitational force of the black hole impacted the time. To visualize this, Einstein wanted us to imagine a space-time fabric, kind of like a mesh, on which all planetary objects are placed. The space-time fabric bends due to the mass of the objects. And when the mesh bends, not only it attracts physical objects more, but it leads to time dilation as well. And the other forms of energy, such as sound, heat, or light, they are affected by gravitation as well. Yup, that's right. This was another conclusion drawn by Einstein. Gravitation affects almost everything. Not only are the physical objects attracted by the force of gravitation, but it attracts heat, sound, and light as well. This means that there can be such objects in the universe which have such a high gravitational force that they can completely absorb light. If there are such objects, it means they'd be completely black. We won't be able to see them because not even light can escape them. This is exactly what black holes are. But when Einstein presented his theory of general relativity, the concept of black holes was merely theoretical back then. Einstein knew that gravitation influences light, and theoretically objects that can absorb light were possible. But Einstein did not knew that there can be actual black holes. In fact, when Einstein was alive, the concept of black holes seemed weird to him. He knew that there can be such things theoretically, but then theoretically the existence of infinity is also possible. And realistically or practically, he did not believe that such things existed in reality. By the time he passed away, not even the term black holes was invented. An interesting and fun fact here is that a key point in Einstein's theory was that the light's speed limits gravity's influence. We don't feel gravity's force instantly everywhere. Its upper limit is speed of light. To use a practical example, suppose that the sun disappeared suddenly. As you know, we'll get to know about this 8 minutes later on Earth, because it takes 8 minutes for sunlight to reach Earth. But according to Einstein, the gravitational impact of the sun's disappearance will also be felt 8 minutes later. Isn't this very interesting? After Einstein, the theory of general relativity was worked on by many other scientists like Carl Schwarzschild, Johannes Droste, and Subramanian Chandrasekhar. There were several equations, They solved those equations and tried to derive the solutions. And by getting to the solution of these equations, it was theoretically proven that things like black holes exist. By the 1960s, researchers and scientists had finally agreed that not only theoretically, perhaps one day realistically, we'd be able to see black holes, because these do exist in space. The term black hole was used for the first time by a magazine in 1964. But only after 1967 did the term gain popularity when physicist John Wheeler popularized it. Even though the term black hole sounds quite sensational, it is a misleading name. Black hole. It might sound like there's an actual hole there, but that's not the case. There's no hole in the space. Black holes are formed by stars, so there's some material at its center. But in the star, there's a continuous nuclear fusion reaction at their center. These reactions produce heat and light. The heat being produced sends a force outwards, and at the center of the star, there's the force of gravity. This helps the star to remain intact and alive. This is how the stars maintain equilibrium throughout their lives. The force pushing outward is due to the reaction, and the force pulling inwards is due to the gravity. But these reactions takes place when a fuel exists, either hydrogen or helium. The fuel wouldn't always be there. It would be burned up at some point. And when the fuel ends, there wouldn't be any forces pushing outwards, and the gravitational force pulling inwards wouldn't be countered by an equal force, so that the star will collapse on itself because of its own gravity. This will take a long time, by the way. Our sun's life expectancy is around 10 billion years. But what happens next depends on the mass of the star. Let's look at the chart of the life cycle of a star. If the mass of star isn't high, that is, if it is a small star, it turns into a red giant, after which it becomes a planetary nebula and then a white dwarf. But if it is a huge star, when it runs out of fuel, it cools down and turns into a red supergiant, and when it bursts, then it turns into a supernova. After this, a tiny core remains. If the core is tiny, it is called neutron star, but anything bigger than that is called as a black hole. Basically speaking, the mass of the star after it collapses due to its gravitational force becomes small and condensed. It can turn into a black hole. Specifically, how small is the volume of the compressed star? For a star as big as our sun, if that turns into a black hole, the diameter of the black hole would be merely 50 kilometers. Can you imagine the volume getting so small? But the interesting thing here is that our sun will not grow up to be a black hole. This was proved by an Indian-American astrophysicist, Subramanian Chandrasekhar. he developed a Chandrasekhar limit value. He said that the maximum mass of a white dwarf can be 1.4 times the mass of our Sun, above which it cannot be stable, and would either turn into a neutron star or a black hole. But since our Sun is under this limit, it will become a white dwarf instead of a black hole. Now that you have understood why black holes exist, now let's understand how black holes are. There are mainly 3 to 4 types of black holes. The first one is stellar black hole. This is the most common type of black holes, the black holes created by stars. Scientists estimate that in our galaxy there are about 10 million to 1 billion such black holes. Then there are the primordial black holes. These black holes are as small as an atom, but their mass is like of a mountain. It is an assumption that they are small as an atom. Friends, these black holes are merely theoretical and hypothetical, and we do not know much about it. The third one is supermassive black hole. These black holes are enormous, so big that their mass is more than 1 million suns combined, and it fits into a ball whose diameter is as big as our solar system. Scientists believe that at the center of every major galaxy there is a supermassive black hole, and that of our galaxy it is Sagittarius A. And the black hole in the film Interstellar, that is Gargantua, was also a supermassive black hole. Additionally, scientists believe that there may be fourth type of black hole too. Though it cannot be said for sure, the fourth type of black hole would be the intermediate black hole that lies somewhere between the sizes of stellar and supermassive black holes, although no proof of it is being discovered yet. One thing that you have seen in the film Interstellar and the photos that you have seen till now and your interpretation about them. The black hole isn't like a big black ball that sucks everything around it. The black holes look somewhat like this. This is the black hole as shown in the movie, because it is HD and more three-dimensional than the photo captured by us some times ago. The first thing that you would notice here in the photo is the orange-colored ring that forms around the black hole. It is known as accretion disk. It is an important feature of black holes. As you know, the gravitational pull in black holes is very high, so due to this gravitational pull, a lot of gaseous matter and debris is attracted towards the black hole and remains floating around it, similar to how the planets revolve around the sun because of the sun's gravitational force. The difference is that the gravitational pull of black holes is more strong than that of the sun's, because of which the things revolving around it has a very high speed and get so heated up that they turn into a flowing fluid like matter. They literally become fire-like particles that are hotter than 1,000,000 degrees. The closer they get to the black hole, the faster they revolve around it. The particle revolving so fast that they get rubbed together and compressed. This causes them to start glowing. They emit electromagnetic radiation, which are mainly X-rays. The accretion disk was depicted very accurately. The only thing which was wrong was the color of the disk. Human eyes cannot see X-rays because they lie outside the visible spectrum. We simply represent it in an orange-yellowish color so that we can depict that there is something around a black hole. The real color of the disk is somewhere closer to blue color. In 2019, the first photo of the black hole was taken. Even in this, the yellowish color was used to represent the accretion disk. Suppose you're falling into a black hole and you have crossed the event horizon, and theoretically there's no chance of you escaping. If not even light can escape it, how would a human? In the film Interstellar, it is shown that Cooper's spacecraft continues falling into a black hole, cross the event horizon, and then suddenly he reaches a 5-dimensional space. This part of movie is purely imagination. It is a speculation, because we do not know what is inside the event horizon. The producers of Interstellar had hired a Nobel Prize-winning physicist to keep everything scientifically accurate. But obviously, things that are yet to be discovered by science, things that we know nothing about, for those parts, the movie turned towards the imagination. what will be at the center of the black hole? Einstein's general theory of relativity tries to explain this. In this theory, the center of black hole is termed as singularity. Singularity is the region of a black hole, that is, the center where the curvature of space-time is infinite. Try to recall the mesh that I had talked about in the first half of the video. The heavier the object, the more of the mesh of space-time will bend. In the case of a black hole, this bend is so much that it stretches the space-time infinitely. As we know that, from the theory of general relativity, time, energy, and everything else is affected by gravity. When the increase in gravitational force is so high, time keeps getting slower infinitely. But what does it mean for the time to get slower infinitely? Does this mean that if you go inside a black hole and if you ever get out of it, the universe outside would be ended for the rest of us? We do not know, and we're not sure about it. We can only make theories. What do you think? Comment down below and let me know. There are some interesting theories that are suggested. Like we cannot see inside a black hole from the outside because the light is absorbed into it. One theory says that inside the event horizon, light reflects off at multiple points before reaching singularity. So it is possible that inside event horizon, things would actually be visible. The things that we have seen for sure about black holes is this single photo. This photo is taken by the Event Horizon Telescope on 10th April 2019. This proved the existence of black holes practically. About 100 years after, they were proven practically. One thing is sure here, if you fall into a black hole, the chances are that you will disintegrate due to high gravitational force. You will die in milliseconds. But even so, there isn't any need to be scared of black holes. Earlier, many people had this misconception that the black holes suck up all matter, keep getting bigger, and eventually it will end the whole universe. But that's not how it works. As I told you, at the center of each galaxy, there is a supermassive black hole. And all other planetary bodies and stars in the range of black hole revolve around it. In the same way that all planets in our solar system revolve around the sun. The same thing happens at the center of the galaxy, but in a much more powerful manner. And the concept of 5 dimension mentioned in the Interstellar is another interesting concept. Let's talk about it in a future video. So that's it for now. If you liked the video, then hit the like button and subscribe to the channel for more such videos. And yes, thanks for watching.